China is moving its future under the sea, and the world is paying close attention. China has launched what could become the world's first large-scale underwater data center off the coast of Shanghai, and the goal is clear from the start. The country wants to cut energy use, support growing demand for artificial intelligence, and solve the cooling problem that limits traditional data centers. If you want to know about the colony China is building, stay tuned for the second half of the video. This is what China is doing right now that shocked US scientists. Modern data centers consume massive amounts of electricity, and a large part of that power goes toward cooling the servers. As AI systems grow more powerful, energy demand rises with them, and companies search for new ways to manage heat without driving costs. The idea of placing servers underwater may sound bold, yet the logic behind it is simple. The ocean stays cool and stable throughout the year, and that steady temperature can replace heavy air conditioning systems. Instead of building giant cooling towers on land, engineers can rely on seawater to pull heat away from the servers. According to company officials involved in the project, underwater cooling can reduce energy used for cooling by as much as 90%. That number alone explains why serious money and research now flow in this direction. The Shanghai project uses sealed yellow capsules that sit on the seabed. Inside those capsules, servers run in a protected environment designed to handle pressure, salt, and moisture. Marine-grade materials protect the hardware from corrosion, and special enclosures keep water away from sensitive electronics. Engineers designed the system so that the servers do not require traditional air ventilation. Cooling flows through controlled systems that transfer heat to the surrounding seawater without exposing the machines to direct contact. Power and internet connectivity travel through submarine cables that link the underwater module to the mainland. Redundant lines provide backup in case one connection fails. Even with those safeguards, engineers understand the risks. A damaged cable or equipment fault could interrupt service, and repairs underwater are far more complex than repairs in a land-based facility. Maintenance teams may need specialized vessels or lifting systems to bring a module to the surface for upgrades. Each step requires planning, cost, and time. The timing of this move makes sense when viewed through the lens of global demand. The world relies on physical data centers to run websites, apps, streaming platforms, cloud storage, and AI models. As more services move online, and as machine learning tools grow more advanced, the need for computing power increases rapidly. Land-based centers face rising land prices, regulatory restrictions, and grid limits in many urban regions. Cooling systems already push power infrastructure to its limits in several cities. Placing servers underwater offers a new path that avoids some of those constraints. China's effort builds on earlier experiments from other countries. Microsoft tested an underwater data center off the coast of Scotland several years ago. That project focused on studying reliability, cooling efficiency, and environmental impact. The experiment showed that submerged servers could operate for extended periods with lower failure rates due to reduced human interference. However, those trials were short-term and limited in scale. China now appears ready to move beyond experiments and into production-level infrastructure. Energy use remains one of the strongest drivers behind this shift. Artificial intelligence requires high-performance chips that generate significant heat. Cooling those chips through conventional methods demands large amounts of electricity. If underwater facilities truly reduce cooling energy by up to 90%, companies could lower operating costs and carbon emissions at the same time. That combination appeals to governments and corporations that want to meet climate goals while expanding digital capacity. Questions still surround the environmental impact. Placing industrial equipment on the seabed introduces new variables into marine ecosystems. Engineers must ensure that heat transfer does not harm nearby sea life. The outer shells of the capsules must withstand storms, shifting currents, and biological growth that can attach to surfaces over time. Long-term durability matters because replacing equipment underwater is expensive. Every design choice requires careful testing. While China pushes forward with underwater data centers, another major underwater project is also taking shape. The country has announced plans for a deep-sea research facility in the South China Sea. This station will be located about 6,000 to 6,650 feet below the surface and aims for completion by 2030. The facility will support up to 6 scientists at a time, and each mission could last up to 1 month. Life support systems will allow researchers to live and work at extreme depths. Engineers plan to equip the station with advanced monitoring tools that track methane levels, ecological changes, and tectonic activity. The focus on cold seep ecosystems shows how serious this project is. Cold seeps are areas where hydrocarbons such as methane escape from the seabed. These zones often support unique marine life and hold significant deposits of methane hydrates. Methane hydrates attract attention because they represent a potential energy source. Reports estimate that the South China Sea contains around 70 billion tons of methane hydrate. That figure equals roughly half of China's current oil and gas reserves. If technology allows safe and efficient extraction, these deposits could play a major role in future energy strategies. In addition to methane, the region holds valuable minerals such as cobalt and nickel, which are important for batteries and electronics. The Deep-Sea Research Station will connect to a network of uncrewed submersibles, research ships, and seabed observatories. Together, these systems will form what scientists describe as a 4-dimensional monitoring network. Data will flow continuously from the ocean floor to surface vessels and then to land-based centers for analysis. That constant stream of information can improve understanding of marine ecosystems, geological shifts, and resource distribution. The geopolitical context adds another layer to this project. The South China Sea remains one of the most disputed regions in the world. Several countries, including Taiwan, Vietnam, the Philippines, Malaysia, and Brunei, claim parts of the area. Building a permanent deep-sea station strengthens presence and influence in a region rich with resources. Strategic positioning often blends with scientific research, especially in contested waters. China's underwater ambitions stand alongside global efforts to expand human activity below the surface. A United States-led project plans to build an underwater habitat near Curaçao in the Caribbean. That initiative involves the National Oceanic and Atmospheric Administration and the Proteus Ocean Group, founded by Fabien Cousteau. The vision includes creating a network of subsea habitats that support marine research, climate studies, and environmental monitoring. Taken together, underwater data centers and deep-sea research stations reflect a broader shift in how countries think about space and resources. The ocean covers more than 70% of the planet, yet much of it remains unexplored. Digital infrastructure and scientific facilities now move into areas that once seemed out of reach. Technology enables this expansion, although the challenges remain real. Underwater data centers must provide long-term reliability before large-scale adoption spreads globally. Equipment failures in deep water required specialized responses. Engineers must maintain strict standards for sealing. Economic models must also show that cost savings outweigh installation and maintenance expenses. Investors and policymakers will watch closely to see whether China's project delivers consistent results over time. The Deep-Sea Research Facility faces its own hurdles. Life support systems must operate flawlessly at great depth. Scientists will rely on stable oxygen supply, temperature control, and emergency systems. Any failure in such an environment carries serious risk. Careful design and testing will determine whether the station can host month-long missions safely. Public perception plays a role as well. Some observers view these projects as bold innovation, while others raise concern about environmental impact and regional tension. Clear communication about goals, safeguards, and benefits will balance how the international community responds. Transparency can ease fears, although strategic competition often complicates that process. China's approach shows a willingness to invest heavily in long-term infrastructure that blends digital growth with marine exploration. Underwater data centers aim to support the rising tide of AI and cloud computing. Deep-sea research stations aim to unlock scientific knowledge and resource potential. Both projects require advanced engineering, strong funding, and sustained commitment. China's underwater push signals that the race for digital power and ocean knowledge now runs deep through the depths as much as across land.